Hello, everybody. Today's lesson, 7.1 on interior and exterior angles. For this lesson, you're going to need your textbook opened up to page 313. And this first activity is one that you can do on your own if you just want to cut out a piece of, just cut out a triangle from a piece of paper. And then if you number the angles 1, 2, and 3, and then tear off each angle. You don't want to cut them because then you can't really tell where your original angle was. So just a tear is great because then you can still see the original angle. And then if you piece them together, you'll see that they make a perfect line. If you put 1 there and 2 there and 3 there, they make a nice straight line. Which confirms that the angle sum of a triangle is 180 degrees. So we've talked about that before. That's the triangle sum theorem, which says all 3 angles in a triangle add up to 180. So we've talked about that, but we haven't actually proven it before. And so now that we know something about parallel lines, we have everything we need to be able to prove this. And so the proof goes something like this. If you just start with a triangle ABC and number the angles 1, 2, and 3, we can draw a line through B that is parallel to AC. And that comes from the parallel postulate that says through every point not on the line, there is exactly 1 parallel line. And so that's what we did in step 1. And now, since line L is a straight line, angles 4, 2, and 5 altogether have to add up to 180. And so angle 1, they're going about it a different way. First, they're talking about angle 1 and angle 4 are congruent because they are alternate interior angles. So that's the alternate interior angles theorem. And then angle 4 plus 2 plus 5 is equal to 180. And that's the angle addition postulate definition of the straight angle. So all 3 angles added together make that straight line, which is 180 degrees. And then if you substitute angle 1 for angle 4 and angle 3 for angle 5, 3 and 5 are also alternate interior. So we didn't finish that part. So since 3 and 5 are equal, we can substitute 3 in place of 5. And now what we have is angle 1 plus angle 2 plus angle 3 must be equal to 180 by substitution. And that proves that the 3 angles of a triangle, 1, 2, and 3, have to add up to 180 degrees. Okay, so since we know that every triangle has an angle sum of 180 degrees, we can start working on this table, which lists the number of sides of a figure and the number of triangles it has, and then the interior angle sum. So obviously a triangle has 3 sides. It's only 1 triangle. 1 times 180 is 180. A quadrilateral, you can cut into 2 triangles. So this one's 180 and this one's 180. And so 4 sides, you can make 2 triangles. 2 times 180 is 360. So the interior angle sum, if you add it up, angle A plus B plus C plus D, that would have to add up to 360 degrees because it makes 2 triangles. A 5-sided figure, we can cut into 3 triangles. So 180, 180, 180. That's 3 times 180. So when we have 5 sides, we get 3 triangles. 3 times 180 is 540. So go ahead and pause your video and fill in the rest of this table. Press play when you're all done. Okay, the remaining part of the table should be 6 and 4, and 4 times 180 is 720. And then a 7-sided figure we can make, a decagon is a 10-sided figure. We can make 8 triangles. 8 times 180 is 1,440. So we want to recognize some patterns here. These numbers just keep going up by 180 each time. Well, from 720 to 1440 is not 180 because we skipped from 6 to 10. But we're looking for a pattern there. And notice that the number of triangles is always 2 less than the number of sides. So if there are 6 sides, 2 less than that is 4. If there are 10 sides, 2 less than that is 8. So the number of triangles that we can make is always 2 less than the number of sides. And so that's where we come up with this theorem that says, for any polygon, the sum of the interior angles is n minus 2 times 180 if the figure has n sides. Another interesting thing to add on to this table, which this book doesn't discuss, but most geometry books do, is the exterior angle sum. So that is, if you have a if you had a triangle, let's say it had 80, 40, and 60, and we put one exterior angle at each vertex, this angle would have to be 140, this angle would have to be 100, this angle would have to be 120. So if we add up the exterior angles, 100 plus 120 plus 140, we get 360. So the exterior angle sum for a triangle is 360. Now what about for a four-sided figure? What if we make a rectangle, for example? All the angles are 90. So if I put one exterior angle at each vertex, that would be 90, 90, 90, 90. 4 times 90 is 360. So the exterior angle sum is also 360. And then for a regular pentagon, every angle would be 108. Because we said it's 540 for the interior angle sum. 540 divided by 5 is 108. So if I put one vertex at each angle, one exterior angle at each vertex is what I meant to say, then we get 72 degrees, 72 degrees, 72 degrees, 72 degrees, and 72 degrees. Add those up, guess what you get? 360. So the exterior angle sum, it doesn't matter how many sides the figure has, it adds up to 360 degrees. 360 degrees. We can also see that using this online tool. There's a link to this on my assignment listing. I think it's called the exterior angle tool. And so this allows us to adjust the number of sides in our polygon, and no matter how many sides it has, and we can even make it irregular if we want it to be a slightly different shape. Okay. No matter what, here I'll reset that back to where it was. And so when I shrink this, watch what happens. The 5 pink angles, the exterior angles, go all the way around, meaning since they go all the way around the circle, they have to add up to 360 degrees. Okay, so those 5 pink angles have to add up to 360 if they go all the way around the circle like that. Okay, we again, if I make it irregular, that doesn't change anything. I can still shrink the polygon and notice that all 5 angles still make a complete circle all the way around. Okay, if I change the number of sides, I shrink it, same thing, goes all the way around, making a 360 degree sum. And so that is why the exterior angle sum for any figure is always 360 degrees. 360 degrees. So, like I said, there's a link to this here. Let's see. right there. Interior, exterior angle tool. So there's a link to that. You can play around with it. Change the number of sides, make the figure irregular, and it still works. All right, so that's the a theorem that's not in your book, which is called the exterior angle sum. So you can say the exterior angle sum if you put 1 at each vertex is 360 degrees for any polygon. The exterior angle sum, I'll say, for any polygon is 360 degrees. And we see that in the table here. All these are 360. Doesn't matter how many sides it has. Okay, so that's an interesting fact that's not in our book. Then we have the interior angle sum, n minus 2 times 180. Remember, n minus 2 is the number of triangles that you can draw. So you don't even have to memorize this formula if you just remember to draw your triangles. Okay, so if you had a hexagon, for example, you just pick one vertex and then draw all the diagonals from that vertex. 6 sides, I get 4 triangles. So 4 times 180 is 720. Okay, example A here, it says for this nonagon has 9 sides. Okay, for this 9-sided figure, find the unknown measure x. And so a 9-sided figure, we would do 9 minus 2 times 180, and that is 1260. So all these angles, all 9 of these angles all the way around have to add up to 1260. So if we know all but one, then we can just say x plus 135 plus 98 plus, and so on, add them all up, all the way around to 25, or 125. That has to equal 180. So if I just subtract all those angles from both sides, then I end up with 158. So x is 158 degrees. Okay, then example B. Determine the unknown interior angle measure of a convex octagon in which the measures of the 7 other angles have a sum of 940. Okay, so if it's an octagon, then it's going to be 6 minus 2 times 180. And so that's, or sorry, octagon is 8 minus 2, which is 6 times 180. And so 6 times 180 is 1080. And so 940 are all the other angles plus x has to add up to 1080, which means x is 1080 minus 940. That is 140. So x has 140 degrees. Okay, go ahead and try problem number 6. Given this pentagon, find the measure of x. Pause your video and press play when you're all done. Okay, for number 6, you should get x equals 135. You can get that by recognizing if this is a pentagon and it's 5, so 5 minus 2 times 180 is 540. So we know all 5 of these angles have to add up to 540. These three are 90. So we have 270 plus 2 x's. It has to equal 540. Subtract 270 from both sides. 2x equals 270. And then x equals 270 divided by 2, which is 135. Okay, go ahead and pause your video again and try 7 and 8. For number 7, the four angles of a quadrilateral have to add up to 360. So x would be 360 minus 89 minus 80 minus 104. We get x equals 87 degrees. In the hexagon, our angle sum is 720. So that means 69 plus 108 plus 135 plus 204 plus b plus 2b equals 720. And so then that gives you 3b equals 204 and b equals 68. Okay, next we're going to look at a pattern using the exterior angles of a triangle. So every triangle, if you draw one exterior angle on the triangle, this is the exterior angle. These three angles, 1, 2, and 3, are called interior angles. But the two that are far away from this one, they're called remote interior angles. So 2 and 3 are called remote interior angles. So the word remote in general means far away, like a remote. You have a cabin in a remote location in the mountains, that means it's far away from everything. A remote control is for changing the channel of your TV while you stand far away. You don't have to be touching the TV. You can be standing far away and control your TV with a remote control. So remote means far away from. A remote control for a remote control car or a remote control airplane, same thing. Allows you to control something from far away. And so this term remote interior angles is going to come up in this next discovery that we make. We're going to go to desmos.com/geometry. You can either watch me or you can follow along with me by going to Desmos yourself. So desmos.com/geometry is where we are. I already created this diagram, but you could create your own using the line tools and the segment tool. What I'm going to do with this diagram is focus on this exterior angle down here, and I'm going to measure that angle. And so using the angle tool, you click on the three vertices that make up the angle with the vertex being in the middle. So I'm going to click here first, then here, and it measures that angle and says it's 148 degrees. Okay, now I'm going to measure the two remote interior angles. So click, measures that angle as 103. So one of the remote interior angles is 103. To get this one down here, I'm going to start here and go click, and it measures the middle angle again, so that's 44 degrees. And so as I move this, do that. So if I go back to the select tool, it allows me to move things. So as I move this, it remeasures all of the angles. Okay, so what we want to recognize is a pattern that shows a relationship between this angle, the exterior angle that's down here, and the two remote interior angles. So this one right now is 138. The two interior angles are 111 and 27. So So see if you recognize, is there any relationship between those? Okay, and then I'm going to move it to a new location. 135 and 115 and 35. How about if I make this 100? This one's 36. This one's 136. If I make this 80, this one is 71, 151. So if you haven't recognized that pattern already, it's that this exterior angle is the same as what we get when we add the two remote interior angles together. 80 plus 71 is 151. When I have this at 100 plus 49, this says 148, it's because there's got to be some round off. There's obviously a little bit of round off error somewhere. So here, if I have 98 and 48, that adds up to 146. And 90 and 63 is 153. 100 plus 57 equals 157. So what we're seeing in all of these is that the exterior angle is equal to the sum of the two remote interior angles. And so that's what we see here. Angle 4 would be equal to the sum of 1 and 2. And so that gives us the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So remember, remote means the two that are far away. So angle 4 is equal to the sum of the two angles that are far away from it. So angle 4 is equal to angle 1 plus angle 2. And the proof goes like this. 3 plus 4 is equal to 180. 1 plus 2 plus 3 is equal to 180. And so this is by the triangle angle sum. Theorem. Those three angles add up to 180. Also 2 plus 3 equals 180 because they are supplementary and make a straight angle. And so by substitution, we have 1 plus 2 plus 3 equals angle 3 plus angle 4. Subtract the measure of angle 3 from both sides. Those are gone. So now we have angle 1 plus angle 2 is equal to angle 4, proving the exterior angle theorem. Okay, so now some problems that we can do applying the exterior angle theorem. In example A, this is an exterior angle. It must be equal to the sum of these two. So we write an equation, 145 is equal to 2z plus 5z minus 2. Solve for z. Z equals 21. Okay, and example B, here's our exterior angle. 3x minus 8 must be equal to the sum of the two remote interior angles. So that one is 90 plus x plus 2. Solving that, we get 2x equals 92 plus 8 is 100. So x equals 50. You can check the work. This is 3 times 50 minus 8, so that would be 142. This is 90 plus 52. 90 plus 52 is equal to 142. So x equals 50 checks out. All right, so go ahead and pause your video and try number 11 and number 12. For number 11, the exterior angle is equal to the two remote interior angles added together. So that gives us 2x equals 20. So x equals 10. It says find the measure of angle n. So n is 3 times 10 plus 7. That's 37. So angle n is, measure of angle n is equal to 37. Number 12, let's see, if the exterior angle drawn measures 150, and the measure of d is twice that of e, so we can say this is x and d is twice that, and then we'd have 150 equals x plus 2x. 150 equals 3x, so x equals 50, which means this one is 50 and this one is 100. And that's it for today's lesson. Have a great day.